There should be more of us out there. The Milky Way may hold billions of habitable worlds, and it's likely been making them for 10 billion years. In less than 1% of that time, a single civilization could colonize the entire galaxy. So even if life is rare, we would just need one spacefaring civilization for the galaxy to be littered with signals, probes, megastructures, something. So where is everybody? Any possible solution doesn't just tell us about them, it tells us about us. This isn't just a puzzle, it's a perspective, a mirror pointed at who we are and where we are headed. In the 1960s, astronomer Frank Drake proposed not an answer, but a roadmap of questions in the form of an equation. The answer, n, will tell us the number of civilizations in the Milky Way currently capable of producing detectable signals, meaning we are not including those that have lived and died, but we are accounting for those that choose to stay hidden. Right now, our galaxy forms about 1 to 3 new stars every year, and most of those stars aren't alone. We know planets are everywhere. Most stars have them. We're talking 80, maybe 90%. Ideally, we need worlds where liquid water is possible. Not too hot, not too cold. That means the right distance from a star and an orbit that isn't too elliptical so temperatures don't swing wildly. We're assuming liquid water is necessary for life. Maybe it isn't, but it's one of the most abundant molecules in the universe, it's an excellent medium for chemistry, and it's the only example we have. Not every star is a safe one. Some burn out too fast, others rage with constant flares. Some host worlds and regions of the galaxy that can be hit by gamma-ray burst or supernova that can sterilize an entire planet. We're looking for planets that are rocky, unlike Jupiter, which is a gas giant with no solid surface. But here's where it gets interesting. Our best guess for where life started on Earth is hydrothermal vents on the ocean floor. They provide heat, minerals, and chemical energy. Bacteria living at these vents today look remarkably similar to what we think the earliest life was like. And vents don't require sunlight, just liquid water and a heat source. Which means life could exist in places we didn't initially count. Moons like Jupiter's Europa and Saturn's Enceladus likely have subsurface oceans heated from below by tidal forces. Our own solar system might have a half dozen worlds with subsurface oceans. Life could be right next door. But now we hit a wall, because the next variables, we have a sample size of exactly 1. What are the odds of life actually appearing? Evidence suggests liquid water existed on Earth about 4.4 billion years ago, and the oldest possible evidence of life dates between 3.8 and 4.1 billion years ago. Life may have emerged within a few 100 million years after Earth became wet. That's fast, really fast, and early Earth was not gentle. Heavy asteroid bombardment, intense UV radiation, and extreme volcanic activity. Yet, life still showed up, which suggests maybe life doesn't need gentle conditions to begin. Maybe it's tougher than we think. Or it can live in protected niches, and we shouldn't rule out a planet for initially appearing hazardous. When researchers mimic early Earth with simple gases and sparks, the building blocks of life called amino acids appear naturally. We find them in meteorites too, even kinds Earth biology never evolved to use. But chemicals alone don't make life. You still need the right environment for those molecules to organize, replicate, and evolve. Maybe what's rare isn't the chemistry of life, but having the right conditions for chemistry to become life. Maybe it's not the miracle of life, but the miracle of Earth. For most of our planet's history, life was microscopic. Single cells ruled the oceans for billions of years. Then some of them stopped competing and started cooperating. But teamwork has a problem: cheaters. So evolution built enforcement, ways to punish defectors and keep the whole arrangement from collapsing. We still carry those mechanisms today. When they fail, we call it cancer. But when it worked, everything accelerated. Muscles, eyes, predation, and eventually, you. Once complex animals existed, intelligence appears to be rather easy. Evolution has found it independently multiple times. Not rocket ship level intelligent, not yet. Just the kind that learns, improvises, solves new problems. Crows and octopuses aren't close relatives. Different bodies, different brains, yet both play, plan, and solve puzzles. The biggest hurdle for intelligence may be getting from microbial life to complex multicellular life. And where that leap does happen, you get ecosystems, forests, oceans, predators, prey, evolution in full swing, and occasionally something thinks. But even then, intelligence alone isn't what we're looking for. Technology needs more than cleverness. It needs knowledge that accumulates instead of resetting. Many animals teach and learn. Meerkats train pups. Chimps pass on tool use. But those traditions rarely scale or compound over long distances and long times. What humans unlocked was rich language, a way to move ideas mind to mind with speed and precision. Then, a system for external memory, shared symbols and durable records, ways for ideas to survive, travel, and build off of each other. That's how one generation's ceiling becomes the next generation's floor. And even when intelligence evolved in humans, Neanderthals, Denisovans, Homo erectus, they all went extinct. Genetic evidence suggests we Homo sapiens passed through periods when our population shrank to tens of thousands, maybe even less. A species soon capable of reaching the stars, nearly erased before ever having the chance. And now, the big one. How long do they broadcast before the signal dies? Not if it dies, when. This is the nightmare variable, because every other variable asks whether civilizations exist. This one asks whether they survive. Whether we survive. We've had radio for 130 years, nuclear weapons for 80, and we've already nearly annihilated ourselves multiple times, and the danger is only increasing. We're altering the climate faster than many ecosystems can adapt. We're writing code into living cells. The ability to bioengineer a pandemic is becoming cheaper and more accessible every year. And most importantly, what began as a tiny academic field only a few years ago has become arguably the dominant force shaping the future of the species. We are approaching the threshold where artificial intelligence can improve itself without human intervention. This is a runaway feedback loop that may be our defining test as a species. We are moving into a phase where our tools grow faster than our wisdom, and that imbalance has consequences. We're at this level of danger and have only been broadcasting into space for a cosmic blink. If most civilizations only transmit for a few centuries before going silent, the odds of two of them broadcasting at the same moment are vanishingly small. Maybe the silence isn't evidence that life is rare. Maybe it's evidence that civilizations are fragile. This is the great filter, where L may not just be a number, but a hint at our fate. The distance between curiosity and catastrophe. Maybe the silence is simply because we are early. Planets with life-friendly environments began forming in our galaxy around 10 billion years ago. It took 40% of that time to go from early life to a modern human, meaning we could be the first. The universe may remain habitable for possibly trillions of years. Most of life that will ever exist hasn't even started yet. Maybe the guests are on their way, forming in stellar nurseries right now, planets cooling, oceans condensing, first cells dividing for the very first time. In a billion years, maybe 10 billion, the galaxy may be full of voices, and we will be the ancients, the civilization that looked into an empty sky and reached for the stars, alone, waiting to say hello. Maybe aliens are out there and just quiet, because quiet is safer. Maybe most civilizations eventually realize that broadcasting your location is incredibly dangerous. Any species advanced enough to hear you is advanced enough to be a threat. So, why would aliens come? Probably not for resources, those are common. If something came, it would likely be a probe, something built to record and report back. And if they were curious enough, maybe they'd come in person. But contact is not just discovery, it's exposure. There's always some chance that what you find, or what finds you, isn't a scientist. It's a predator. A civilization that sees your planet not as a wonder, but as an opportunity. And even if that chance is small, the downside is enormous. When the cost of being noticed is possible extinction, curiosity takes a back seat. So maybe the wise civilizations, the ones that last, stop broadcasting. They listen, but never speak. Which means we might be the naive ones, the cosmic toddlers, shouting our location into the void. We've been broadcasting our presence for about a century. Those signals are now 100 light years out. They could have reached over 100 planets that are possibly habitable. If anyone's there, if anyone's listening, they already know we're here. Or maybe aliens talk to each other and have a galactic consensus. Let them evolve naturally. Let them make their own mistakes. Let them discover their own solutions. And once you survive your own instability, you earn the right to contact. From their perspective, we're still in a dangerous stage, a young species armed with primitive weapons and unpredictable instincts. So they watch, not in malice, but to see whether we pass their test. Okay, time to really go off the deep end. From relativity to quantum mechanics, reality has repeatedly turned out to be nothing like our intuition said it should be. Why would future intelligence be any different? We keep imagining aliens as slightly upgraded humans, carbon-based, planet-bound, broadcasting radio like it's 1955. But even if aliens are a reflection of ourselves, we went from horses and paper maps to rocket ships and GPS in less than a century. And we couldn't predict any of these 50 years ahead with any confidence. So why do you think we can imagine a civilization 1,000,000 years older? How it travels, what it wants, whether those words even apply. We might be listening for radio signals from a civilization that abandoned radio, the way we abandoned smoke signals. Why assume an advanced civilization is still shouting into space? They might have migrated inward, abandoned expansion. They might run on matter we can't probe or scales we don't monitor. From the outside, that would look like silence. But silence isn't proof of absence. It just means we're still asking the wrong questions, using the wrong instruments, searching for a mirror instead of something truly alien. We've been listening for 70 years, and in all that time, the universe has offered us nothing but quiet. Nothingness that can mean 100 different things. None of them comfortable, all of them ours to sit with. Every answer changes everything. If we're rare, then we carry the weight of being the universe's only chance to understand itself. If we're fragile, then we may be approaching the test that almost no one passes. If we're being watched and performing on a stage we didn't know existed, then we're waiting for approval and recognition from higher beings. And if we're early, if we're the first, then the choices we make now could shape the entire future of intelligence in the galaxy. We didn't choose to be here first, or alone, or early, or whatever we turn out to be. But we do get to choose what we become, while the question is still open. And maybe that's the real message, buried inside the silence. The future, for now, is ours alone to create.